Let's see here. So far, I see Braylon, I see Chase, Braylon, I see Colton. Courtney, you are not on my attendance roster anymore. Let me double check it, make sure I'm not lying. Courtney, you're not on any of my rosters. Oh.
Morning update. Good morning to everyone at AHS. For your safety,
let me double check my other periods.
Note that no pre-screening is required for every person before you enter our campus. Nasal ISD and Nasal High School will follow all Tarrant County public health guidelines as well as all CDC requirements. Masks are required for every person on our campus, so please be sure you're wearing a mask that covers your mouth and your nose for the entire day, all day.
Let me see if I can figure out where you're supposed to be.
School safety is our top priority at Nasal ISD and
Come on, computer, please don't do this to me today.
If you have any questions or any concerns, please don't hesitate to contact one of our officers in the hallway. One of our administrators will be glad to.
My computer's being snail slow. Here we go. Schedule.
If you don't have your ID, if you're returning from remote learning, if you do not have an ID, please be sure that you check in the library. You can do the QR code. They will be getting back with you for your ID. So please take care of that. And again, students, we ask you to please wear a physical ID. This is a district requirement. Hope all of you have a great day here at Hazel High School.
Okay, so real quick, Courtney, I just looked up your schedule. I have no idea why everything has changed. And I don't know how to send this to you, but where you really should be right now is English 3 with Crow. And then after that would be aquatics with Miss Smith. And then business info management with Noel. Then English 4 with Taylor. Then principles, I guess that's floral design with Kiggins. Then economics with Mabry. Then U.S. history with Hughes, and then Apex with Boyer. I have no idea why your schedule changed, but you're not in any of my classes. If you, I guess I would contact the office, your counselor. I wish I could tell you more, but I don't know what to tell you. But you're not in this period anymore. All right. Let's see here. Let me go back. Sure. All right. So let's see. Who else do I have? I've got Joseph, Sarah, and Taylor. Okay. So we're not going to have the time issue that we had yesterday. You guys only had 20 minutes in here. So I'm going to go ahead and do what we should be doing today. And then I will come back. I'm going to stop the recording. I will come back. And because I wrote down where we left off, and we'll pick up the important stuff. Yesterday, we started going a little bit more into plate tectonics. That's what we're focusing on this week and next week. Get my and unfreeze this would be good. For the opener, and I'll go through, hopefully I'll have enough time and go through and let you know if you didn't do the opener or the assignment yesterday, because it's not gonna shut down today, but I always let you guys know if you're missing something. All right, so Wegener. We've talked about Wegener a couple of times. Why did continental drift not work? Why was that thrown out? There was lots of stuff. Okay, they didn't have the technology. They didn't know that there was ocean crust. They only knew it was continental crust. They didn't know about the magnetic striking on the seafloor, which was the last thing that we would have talked about yesterday. We talked about that before the break too. You didn't study ESS over the break. But yeah, this poor dude, like none of his colleagues agreed with what he said because there wasn't enough proof to back it up. And he had a lot of evidence. And we're going to talk about what he knew, and then we're going to talk about more modern, the technology stuff. But continental drift was completely and totally thrown out. It's the name of one of the ice age movies. Like tectonics is not continental drift. It's not the same thing. It's related to it, but it's a lot more in depth. Go forward. All right, so we're gonna go back over what he did first, which we did before the break, and we're gonna go into modern stuff. Alright. That picture didn't animate. Like, we know that the Earth is broken into many plates. There are about 12 larger plates, and there's a bunch of minor plates, like the Fuca plate and the Nazca plate. There's smaller. Big plates are like the North American plate, or the Australian plate, or the African plate. It's normally have continents that are riding around on top of them. And they're moving. Now they're moving very, very, very slowly. Now, as fast as your fingernails grow. Somewhere between 1 and 10 centimeters a year. Well, I said approximately. No, don't be the last one. I swear. Now, where these things interact with each other, we have some type of geological something going on. And depending on what type of boundary is occurring and what type of crust is interacting is going to determine what type of, is it an earthquake, is it a volcano, is it a trench, does it make a mountain? Like I said, we talked about this before the break. We had 2 little sections that introduced plate tectonics. I don't think I have one more on here. On the right page. Oh, there is one more. These deep ocean vents, that's what that's an image of over on the side. Well, that's where life began. Life did not begin in the sun. It began at the very, very, very bottom of the ocean, where light cannot go. And the life there was not photosynthetic, it was chemosynthetic. And every time we've had horrendous, like the Permian mass extinction, which wiped out like 85% of all life, that's where it started again. And made its way back up. Now the sun can go out. And the things that are down there, the bacteria, which is the beginning of the food chain, the crabs and the shrimp and the fish and the tube worms that use that bacteria, they don't care. They're still going to live for a little bit. Now, if the earth totally dies, like the core dies, then that stuff's going to go away because they live in over 400-degree weather. It's literally an underground volcano.
So, okay, so you said that basically life was started like after the mass extinction. So, to think about like right now, what would be like, I feel like, use the head and more right now.
Do what?
It would be like a few years ahead that wouldn't have happened. Like technology, like us.
Well,
It's so dark in here.
Where- you need me to turn on all the lights? Really? Okay, one lady says no, turn the lights off. Anyway, we are very much tied into our technology. Most people say let's be bright. We got the other way around. I don't think it's really gonna matter. Okay. We human beings have only been here for a very, 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 very short period of time. And obviously, we think we're the most important because we're human. And, you know, we're the ones that have the giant frontal cortex or the frontal lobe. There will be things that are going to be here much longer than us. Things like cockroaches. And so these circular patterns that are in the mantle, it's not a liquid, it's a plastic, not like this plastic, but it's a very slowly moving solid, just like the glass that is in the window. That glass is moving, it's sinking. It just is so slow, you don't see it until that glass has been sitting there for a few hundred years. You ever been to an old church? Like old church. Look at the windows. Well, they're skinnier at the top and they bulge at the bottom because the glass sinks. It does it so slowly. If I run over there and punch that window, I don't think I'd break it, but I could. So, no, we're not going to go punch the window. Fine. So the cooling of the earth And then the heating inside the mantle, and then the cooling of the earth. These are called convection currents, but gravity has a part to play with this too. These plates that are subducting, this oceanic plate that they can't see online, this oceanic plate that's subducting underneath the continental, eventually, if this doesn't melt, it doesn't go deep enough to melt, there's enough of it that's hanging off where it literally breaks. And the gravitational pull of it being moved underneath the other plate helps pull those plates across the surface. All right, so lithosphere means the rock. Okay, we think of the hard part that we talk on, that the very top of the crust is, compared to the rest of the planet, it's really not that thick. But the crust, the continental and the oceanic, is give or take 90 kilometers thick, about 10 of which is oceanic. And if you're on Mount Everest, there's your other 80. And not the entire continental crust is 80 kilometers thick. It's gonna be up on the top of your mountains in the Himalayas and in the Andes. The lithosphere is the two crusts and the upper part of the mantle, specifically the asthenosphere. Now, I don't think I got to the MOHO in this class yesterday. The MOHO is the boundary between the crusts and the asthenosphere. It's like a very, very, very thin line, and I should be able to come back and go over that. But for some reason, I did put fifth period in Canvas in the entire thing recorded. The lithosphere is very, very, very brittle, and it breaks. And when it breaks, we call those earthquakes. We will have a section just on earthquakes. I think it's Friday. It's not Friday, it's the beginning of next week. We have all different kinds of geologic activity that occurs where these boundaries either collide or pull apart. Asthenosphere, the very upper part of the mantle, right underneath the crust. That's the part that moves the plates. We've called it a conveyor belt before. The fancy term for plastic is viscoelastic solid. It's not like a rubber band elastic, but it moves. Like I said, and it's not like this kind of plastic. Very, very, very slowly moving solid. You know, these convection currents underneath, they take hundreds, if not thousands of years just to make one turn.
So it's like oobleck.
It's like what?
Oobleck.
What the heck is oobleck?
Oh, I thought things like where you mix water and cornstarch. Yeah.
I've never heard that word before.
Well, like, so you get this or you
I know what you're talking about. Like if you grab it, it's like a solid, and as soon as you stop moving it, like
yeah.
But I've never heard that word before. We used to do that when I taught IPC.
What was it called?
I don't remember what it was. Just
Water
it's like cornstarch. It's just cornstarch. It has water in it. If you take that stuff and you put it on a speaker, like in a petri dish, you put it on a speaker and turn it up, it like crawls around and like dances and stuff. It's really cool. Pangea. Pangea was the name of the continent. Panthalassa was the name of the gigantic ocean where there was not land. You've probably heard of Pangea before, but not the other one. What split it in two? Y'all remember? No. No, there's a name for the feature that no. No. Oh my gosh. The Mid-Atlantic Ridge. The Mid-Atlantic Ridge is literally this.
You think?
Hey. I haven't gotten that far into it. I mean, they're still moving forward, but what happens if they go all the way around to the other side? They will connect them. So, now how long is it going to take? We will not be around to see it. I guarantee you, human beings will be extinct by it.
I'll be the last one alive.
Thank you. Now, Wegener, he took a look at very, very specific fossils trying to prove this continental drift. We're not getting into dinosaurs quite yet, but there were two, actually there were four, but there were two in particular that we're going to talk about. Now, we don't have this image. So this guy, this mesosaur, go away, black bar. They were found on two completely, totally different continents. But yeah, that ocean didn't always used to be there. They used to be closer together. This is not a swimming reptile. This was a freshwater reptile. Not like what's the one with the long neck? Anyways, I have to brush up on my dinosaurs.
Long neck sword.
Long neck dinosaur.
Long neck bottle.
And it didn't have the ability to swim large distances. So that was one of the ones. And this is how you spell Mesosaurus.
Bottleneck dinosaur.
Bottleneck dinosaur. It starts with a
Tomboy.
So we're not doing dinosaurs yet. That would be
T-Rex.
So that's T-Rex. Now the Glossopteris, that was a fern, and it was really the Glossopteris that pointed out a bunch of very interesting things to Baker. Now we find those fossils in Antarctica.
Oh wait, Antarctica has like actual.
Has huge coal deposits. Antarctica didn't always just be there.
Huh.
Be a lot more north.
Wouldn't the water still be? Oh.
Be right. That's why I said I have to brush up on my dinosaurs. Well, that's a brachiosaurus. No, I'm talking about the marine one. The one that they think the Loch Ness monster is. Well, and then the depressing thing on here, he went to Greenland, which is just a giant glacier. He went to Greenland trying to find more of these fossils in these coal deposits, and he died from exposure in 1930.
Wait, so didn't they name Greenland like that?
Greenland and Iceland were named the wrong way on purpose.
Was it
Vikings.
Greenland?
Vikings trying to, huh? Yeah, to make them go to the wrong place, specifically the Vikings.
Wait, really?
Yeah, really. We'll have a documentary that we're gonna watch on Iceland next Wednesday.
Iceland.
Yes, Iceland's basically a gigantic volcanic.
I want to go there.
I think it actually be an interesting place.
We should go on
A field trip to Iceland. Yeah, there we go. There we go. All right, so there are huge coal deposits that are found in Antarctica. Like I said, Antarctica was not always there. It used to be a lot more north. We find huge glacier deposits in South America and in Africa. They're not cold there, but we have these what are called moraines. We have these evidences of the fact that glaciers went across their surface, which means they had to at one point in time be a lot further south. So they said Wegener was doing things the right way. He just didn't have the technological advances to understand those missing parts. I can't remember if there's one more on here or not. No. So like I said, that fern, that Glossopteris being found in Antarctica, I can speak, was sort of like the missing thing. And then he went off to Greenland to try to find more, and he died from exposure to the cold. And so this is an image of, as far as the glaciers are concerned, that when these things were much closer together, they said there's not glaciers on these anymore. Obviously, they're Antarctica's giant sheet. No, India, now, may have mountains, but it was way the heck up here. So that was another big thing that he came across. Now, seafloor spreading. We talked about this before. You have the plates pulling apart. They're diverging. Okay, it cracks. The magma comes up. Technically, it's lava. Once it comes up, cools. It pushes those plates just a little bit further apart. Rips again. Pushes them just a little bit further apart. Seafloor spreading actually has taken pictures of the past. Because that iron, as it comes up, if we have a pole reversal, it's frozen, either the correct or in reverse polarity. We call that magnetic striping. That was one of the things we should have ended with yesterday, but we did talk about it before, and we'll talk about it again. Wegener did not know about this. He said he didn't even know about oceanic crust. The Mid-Atlantic Ridge. They're all important, but this is the one that broke up Pangaea. the one that goes all the way basically from the north to the south pole, not 100%. It stops at the Antarctic ridge. This is what pulled apart that original continent. This is what's pushing the western hemisphere to the west and the eastern hemisphere to the east. And at the ridge, you have the youngest rock. The further away you go from the center, the older that rock becomes. It is the absolute longest mountain chain on the planet, and most of it is underwater. I'm gonna do this. I'm trying to get my chemistry lab working on finding the complicated.
Use fire. Yeah, boil it, it's fire.
The yeast doesn't activate right in regular temperature water. It can't be hot because it'd kill the yeast, but it has to be warm.
So you said it was killers?
Yeah, it'll kill the yeast. Yeast is alive.
Wait,
It's a
really?
living organism.
No.
Yeah, it's part of it. Not all beer. Actually, I don't know. I've brewed beer before. I don't. Sorry. Although I do know that it was the Egyptians who invented beer. I know that. 5,000 years ago.
They were smart.
So
Honestly.
this is an image of magnetic striping. Okay, so the different colors. So the youngest is here in the middle, which is sort of like an orangish color.
So magma's like,
It's the iron.
oh,
It's the iron that's in it. Okay, so you have the iron that comes up with the magma. Okay, and as it solidifies, the iron aligns with magnetic north and south. Turns into rock and is trapped as frozen. Okay, so let's say we have a pole reversal. And every 500,000 years, give or take, we have a pole reversal. When that magma comes up, that iron is now flipped. And it gets trapped. And so you see these stripes of what we consider normal, which is now, and then reversals that are literally trapped in the rock.
so when we have like a pole or whatever, north would be south, south. would be-
Yeah, the Earth doesn't flip, but magnetic north and south are opposites. And we're having a lot of pole wander right now, where it's like wobbling. So we're thinking we're getting really close to another pole reversal.
Who's that?
That, that, not just
Depends.
electricity and all that.
Anything that runs off of magnets will not work anymore. So basically everything that we use. And that's if it's a quick reversal. Now, if it's a really slow reversal, we don't have a magnetosphere to protect us from the sun, and everything fries. Some of those things at the bottom of the
Wait,
ocean.
so if that, so, anyway,
I'm not making this up. I mean,
so if that just, whatever just happens, then everything is going away, like,
anything that runs off of magnets.
how?
You can, magnets are magnetic, but everything,
Well, no.
computer chips.
So basically.
If we have a reversal, they don't work right.
Basically, we're living back in like the 1800s.
Now, if you have a car that has a carburetor in it, those don't have all the fancy stuff. Those would probably still work. I don't know how you get the gas to come up through the pump and everything like our sewage system, all of that would fail. You don't realize how much we have based our technology with magnetism. Basically, this is planet's a giant magnet. Anyways, I'm not running out of time to go back over the stuff that we missed yesterday. Huh? No,
My son-
Okay, so-
Also, compasses wouldn't work either.
they would be pointing the wrong way.
Yeah, so then,
But so north would look like it's south. EMPs. Yeah, well, I teach physics. We go over all that stuff. Now, if you have a Faraday cage, the stuff that's inside it will be okay, will be protected. Like if the EMP doesn't just bite it, kill it. But everything else would have been destroyed. So Yeah, it's an interesting conversation when I teach physics and you get into electricity and stuff. It's one of my favorite units because I get to shock students and not get in trouble. Volcanoes, earthquakes, and mountains. Huh?
We should make a GMT bomb.
No!
Yeah.
These are the geological events that occur at boundaries. I have talked about the Ring of Fire before. We will have a lesson specifically on volcanoes in the future. We'll have one on glaciers. We'll have one on ice ages. We're just not there yet. We're doing plate tectonics right now. All right, the Hawaiian and the Canary Islands. These are hotspot creations. Okay, a hotspot is when you have this plume of magma not at a boundary. I mean, Hawaii's in the middle of the friggin' plate, but we have this hotspot. We have this plume that comes up, and as the plate moves, the hotspot doesn't move. As the plate goes across the hotspot, it starts punching through from time to time. So when you look at Hawaii, I can't remember the little one way on the end, but there's a little one that people aren't allowed to go to except for natives. And then there's, I think it's Lanai, and then it's Kauai, and then like, but as you go further west, those have been there longer because the plate is moving this way across the hotspot. Hotspot doesn't move. So the big islands, the one that you really don't want to visit because it's a tourist trap and they hate mainlanders there. That's the newest island. It also has the most activity because it's directly over that hotspot. The Canary Islands are the exact same thing. They're out in the middle of the plate. Not at a boundary. It is a hotspot. Okay. Now, we're getting into more technological stuff. A seismograph, I think there's one more, is a machine that records the energy as it's released from a focus, from a fault, from a crack, from an earthquake, as it travels either through the upper part of the crust or all the way through the earth to the other side. We have seismographs all around our planet, and they are constantly taking data. When we have an event, if you have 3 different observatories, well, you have to have at least 3 to triangulate, you can figure out where that earthquake started from. Now, depending on where the waves are picked up, that's how we can tell how thick different parts of our Earth are. S waves can only go through a solid, which is the crust and the mantle. So they can't be found all the way on the other side of the planet because it can't go through that liquid outer core. P waves, however, can go through a liquid. So taking a look at how long it takes, once you know your epicenter, to get from point A to point B and how it bends as it travels through the Earth, lets us know that the core is solid, it's a certain thickness, the outer core is liquid, it's a certain thickness, the mantle is that plastic, which actually acts more like a solid, it has a certain thickness, and then the crust is so thick. Now, the shallower the waves are recorded, the better the image is going to be. Which I can't remember if we got to that slide yesterday or not, because we didn't have a lot of time yesterday. So it's the timing between them that lets us see. Before the break, people were like, well, how do we know that it's really a liquid outer core or a solid inner core? I was like, we're not there yet. Okay. Did we get to reflection, refraction, and attenuation yesterday? Okay. Refraction means bending. As it goes from one density to another, if it's less dense, the wave, if we're talking like a regular X and Y, if it's less dense, the angle that comes in, it will bend more towards the X. If it's more dense, as the angle's coming in, it will bend more towards the Y. I know the Earth is not flat, no matter what people say, it's not flat, it's 3-dimensional sphere. So it does it on all 360, but it's the X, the Y, and the Z. Y'all, I'm not going to make you do the geometry and the mathematics behind this. But the changes specifically in the P wave, that's what lets us see deep in the Earth. Taking a look specifically at the S wave gives us all the detail of the crust. This image you guys should have, I think it's on the back if you have the paper copy. This is what the interior of the Earth looks like from a seismic point of view. This is what we're measuring. So S is the black line. I know you're on paper, it's all black, but yellow is the P wave. The S's can glance off that outer core but not go through it. But the P's can go through. Now we do have, if we're looking at the shadow for an S, this entire part would not have any kind of seismic readings for S waves. S stands for secondary or shear. The P's, because of the refraction, the bending, it has two small areas that have shadows. So there would be no seismic activity. If this is your epicenter, there would be no seismic activity over here at all. This section would only be P, and then up here would be both P and S. Now there's more than just S and P. If it's a P wave and it goes, see, it's P, K, I, K, P, if it goes all the way through, but I'm not going to go that far into it. I think that's the last one. It is. Now let me pause this first, and I'm going to go, let me stop my thing, because I'm going to go